When you are building machine learning systems, the hardest part is often not the model itself. It is the data pipeline that feeds it, specifically when you need to query relationships in real time. Imagine you are running a fraud detection system. You need to know if a transaction is connected to a known bad actor within 3 hops. If you use a traditional graph database, you are sending requests over a network to a separate server process. That adds latency. Every millisecond counts. This is where a new player named Grafeo claims to change the game. It is a graph database built in the Rust programming language that is designed to be embedded directly into your application. Here is the thing about embedded databases. They are supposed to remove the network round trip. You do not have to manage a separate service. You do not have to worry about connection pooling or network timeouts. The data lives in the same process as your code. For machine learning operations, this means your feature store can query neighbor relationships at the speed of memory access. No network overhead, no serialization delays, just raw computation. Grafeo promises to leverage Rust's memory safety and concurrency model to achieve performance that Python-based alternatives simply cannot match. Consider the typical workflow of a data scientist. They often write prototypes in Python because it is easy. They use libraries like NetworkX or Neo4j drivers to handle graph queries. This works fine for development. But when you move to production, you run into the global interpreter lock. This is a mechanism in Python that prevents multiple threads from executing Python bytecodes at once. It means your application becomes single-threaded for those critical graph operations. If you are processing millions of connections, your application slows down. Grafeo solves this by running in a compiled language. It compiles down to native machine code. This means the central processing unit does not have to interpret instructions at runtime. The result is a system that can handle heavy concurrent loads without the overhead of a garbage collector stopping the world. Now consider the architecture. Grafeo is lean. It does not have a heavy server daemon running in the background. It is a library that you link into your binary. This is a significant shift in how we think about data infrastructure. Traditionally, we separate our data from our compute. We have a database server and an application server. With Grafeo, the database becomes part of the application. This enables what some call serverless or decentralized data architectures. The database lives directly within the application runtime. This is particularly useful for edge devices or microservices where traditional graph databases are too heavy to run. You can ship the graph engine with your container or even your mobile app. There is a compelling argument for why this matters for neighbor lookups. In graph theory, a neighbor lookup is finding all nodes connected to a specific node. In a social network, this is finding friends of friends. In a knowledge graph, this is finding related concepts. When you do this in Python, you are often limited by how fast you can traverse pointers in memory. In Rust, you have explicit control over memory layout. You can optimize the storage of nodes and edges to fit perfectly in the central processing unit cache. This reduces cache misses. Every cache miss is a trip to main memory, which is significantly slower. By optimizing for locality, Grafeo claims to offer potential improvements that are an order of magnitude faster than interpreted solutions. Some benchmarks suggest 1,000 times the speed in specific scenarios. However, we must address the elephant in the room. The project is very new. There is significant skepticism in the developer community regarding its maturity. Discussions on forums like Hacker News have questioned the authenticity of its rapid progress. The commit history shows an unusually high volume of code generation in a single week. This suggests a heavy reliance on artificial intelligence tools to write the code. Critics argue this approach may result in a fragile system lacking the rigorous design typical of established graph databases. While proponents highlight Grafeo's potential to rival modern engines like Kuzu or DuckDB, there is a notable lack of independent validation regarding its performance benchmarks or confirmed production usage. So, is it safe to use? For a production feature store, caution is advised. You need to know your data is not going to corrupt silently. You need to know the queries will return consistent results. Until independent audits or widespread adoption occur, Grafeo remains a promising but unproven experiment. It is viewed by some as a portfolio piece rather than a mature product. But for a proof of concept or a specific internal tool where speed is the only requirement, it offers a glimpse into the future. Think of it this way. Using a traditional graph database for machine learning is like driving a truck to deliver a single letter. It works, but it is overkill and slow. Using Grafeo is like having a drone that flies directly to the destination. It is faster, leaner, but the technology is still being tested. If you are building a system where latency is the primary constraint, Grafeo offers a path forward. It allows you to treat your graph data as a local resource rather than a remote service. This changes the way you design your system. You stop worrying about network partitions and start worrying about network partitions and start worrying about memory safety. The implications for the future of machine learning operations are profound. If this technology stabilizes, it could disrupt the embedded graph database market. It pushes us toward a world where the database is not a separate service you manage, but a library you import. It eliminates the need for a separate process, reducing the attack surface and the operational complexity. For developers who value the Rust ecosystem, this is a natural evolution. It combines the safety guarantees of Rust with the structural power of graph data. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.